Board.
There you go.
I see live.
They're live now, yeah.
We don't click on that.
Nope, just
nope,
go
don't touch
ahead,
the thing.
Ron.
We're on, by
Start
God.
talking.
Hey, everybody. Good morning. Welcome aboard. Are we streaming live there, Tom, on YouTube? People
Yep.
can watch us. Mostly, actually, Tim Crawford will be on board, I guess, watching us, and anybody else that wants to join us. Welcome aboard. It's episode 18. We've done 17 of these in the 2021 series of the SBAU Astro Hour. And doggone, it's series 18. Welcome aboard. It's a weekly podcast from our different rooms, our men cave and living rooms. Santa Barbara's Astronomical Unit is alive and well. It's the longtime telescope and astronomy club. We're going to get into some heavy stuff at times, but talk about space news, launches recently, new discoveries, exoplanets and black holes. And we get into it and try to make it very understandable. This week, before I introduce you to the gang, my name's Barron, incidentally, Vice President, proud to be. We'll be talking about Cassiopeia, the Queen in the night sky, starting this week. We'll talk about the Oort cloud with two O's, discovered or actually postulated. I'm not sure if it's actually been seen, but it's out there, way out there by Jan Oort back in 1950. We'll cover the night sky, and we'll even mention President Jerry's forwarded cartoons. I'm not sure if we'll talk about the expanded new Hertzsprung Russell diagram that was talked about last week, but let's meet the gang. President Jerry, I'm not going to say where he is on my screen. I just learned that everybody's reconfigured on their own laptop screens or computers. Jerry Wilson, good morning, sir.
Good morning.
Happy birthday. We won't say
Thank
what
you.
that was yesterday. I hope your wife took care of you. Pat Forgy, he's married to. And again, missing going once a month on the first Friday to get together, all of us. Let's meet our outreach coordinator, ChuckMcP there.
Morning.
His wife is also Pat. She's our merchandise manager. On my upper left screen is fresh back from Michigan, my friend Tom Totten, who's running the show. How are you, Tom? Webmaster?
Doing good, thank you.
Okay. Did you get last week's show back on YouTube afterwards? Because the hookup didn't happen as we were talking. But
yes, I did. Yeah.
so all 18 of these, including this one, are being archived. At the bottom of my screen, on my bottom left, but it could be anywhere on yours, I'm now learning, is Tom Whittemore. How are you, Tom?
Morning. Hi, good morning, Ross.
Former Westmont College series instructor who I don't think wants to go back, right? Or are you home forever? Are you retired?
Oh, I'm retired. Yeah.
All right. Well, he's baking bread, and that's what he does well. Also
Did it
edits
this morning.
Did you?
Yeah.
Hey, do you have a gift coming to you there, Mr. President Wilson, or not? Tom's married to Maureen. He's the editor of our SBAU newsletter. And doing double duty, longtime active member Bruce Murdoch, whose wife is Bonnie, is also president, ladies and gentlemen, of the what is it? Theater Organ
TOS.
Yeah, Bruce.
Santa Barbara Theater Organ Society.
Did you guys have your big meeting inside the Arlington recently?
Well, we were going to have, do theater pipe organ accompaniment to the virtual parade, but that was disorganized, and they wanted our organist to drive up from North Hollywood to do 5 minutes worth of bang, bang, bang on the organ and then go home. And he says, no.
He said no?
No.
Was this for the solstice parade?
The solstice parade, right.
Yeah, and it all went virtual. I didn't understand that. How do you have a parade virtual? Everybody lines up.
Well, they videoed the individual presenters that would have been in the parade, and then they put them together as a video that they showed in the Arlington.
So I got a question for Bruce. It's a little on this topic. Bruce, did you hear about that fire in Iowa that destroyed basically a major producer of pipe organs? Did you read about that?
I've heard about it peripherally. I need to investigate that.
Yeah, apparently the whole place just burned to the ground. Major supplier, I can't remember the name. It was in the New York Times a handful of days ago.
Well, the major material that's used in the making of organs is wood, and they let it dry for years and years, so it's dimensionally stable. And so you've got a tinderbox there.
Yeah, thanks,
like
Tom.
Look,
It's
look at the
Dobson.
name of that pipe organ builder.
Dobson Pipe Organ Builders.
That's right, Dobson. That was it.
Dobson, never heard of them.
Okay,
Dobsonians.
so I,
Same company makes the telescopes?
No.
No.
Oh, okay, just happens to be the,
yeah,
It was in the Times. It was a pretty big story in the
okay,
Times.
that's our commercial break, folks. Let's get back.
There we go.
we have some sad news to report, and I'm going to throw it to Chuck McPartland about one of our members we lost recently. What happened and who was it, my friend?
Well, it was Ace Angeloff, Peter Angeloff, who's a longtime physics teacher at Laguna Blanca High School. And he was a member of the Astronomical Unit in the sense that he would, he had a corporate membership in effect. His students would get extra credit for coming to our star parties. And he would show up and ask them questions and, kind of shepherd them around the telescopes. And he was an avid motorcycle rider. And last week he was killed in a motorcycle accident on 154, a single vehicle, he just went off the side. So
Laguna
bad
Blanca.
news.
Yeah, he taught science there, right?
Yes.
And well, I wonder if I ever met the man.
You'd
He's the one that-
remember him. He would roll up to the star parties with a big rumble, and was had a very strong voice and was always jovial.
Yeah,
He just
Well-
had Laguna Blanca donated a old C8 telescope to us for resale and needs to be cleaned up. But I just had met him at Laguna Blanca there just a month ago.
yeah, we're very sad to hear of his passing.
And we need new expanded membership. The younger, the better in some cases, but we may or may not be able to reconvene this year up at our beautiful Museum of Natural History, depending on how things go. We have gotten rid of our masks. Mr. President, what would you like to start talking about? The night sky, or you go right to the Oort cloud, or Cassiopeia, the queen, the big W?
You're the master of ceremonies.
Well,
What would you like to
okay.
hear about?
This is what I wrote down first. You should see my scribbling, man. I do get it in there, and I'm writing better and closer, and I get it all on one page. General sky news is what you said. As the sun sets this week, I assume it's not any particular night here. Cassiopeia, the queen, is let me throw my little light on it here. Is starting her upward arc into the sky, circling Polaris, the North Star, which tells me and would tell anybody else it's not on the zodiac. Cassiopeia is one of the several circumpolar constellations close enough to the North Pole that it appears to rotate around it, usually above the horizon.
For our latitude, that's true.
Okay. Yeah, it's
Without
one
our
of the.
mountains, especially.
Is this an asterism? It's not is Cassiopeia. What is it exactly? What does it become?
Constellation.
I know it is a constellation.
It's an asterism. It's an asterism and a constellation.
Yeah.
Really?
It represents Cassiopeia, the queen of Ethiopia, but it's more her throne than anything else.
Okay, well, this is the first time I've ever read, and I'll try to share these with you with the right pronunciation. You'll correct me, of course. These are the stars involved. One is Segin, Segin, Epsilon Cas. The other is Rukva, or Ruchba, Delta Cas. Navi, the star Navi, Navi, Gamma Cas. SCHEDA, I can't read the last letter. Shadar something.
Shadar.
Oh, it's an R.
Shadar.
Shadar, which is Alpha Cas, and CAF, CAPH, which is
Yes.
Beta Cas. And those are the stars in the W. There it is.
Yeah, and you'll
Okay.
notice that the thing that your eye picks out in the star real easily is the W shape with those 5 stars. There's extra lines drawn on the planetarium software that I'm using, which is the Sky 6, that are officially part of the constellation, but your eye really goes to just seeing the W. So forget those other 4 lines. The
Okay.
circle, the red bullseye down in the right is indicating the double cluster between Cassiopeia, and then it in the bottom right are a couple of stars of Perseus. And so between the constellation of Perseus and Cassiopeia is this double cluster, which you can pick out with the naked eye on a very clear night as a very faint fuzzy patch. So, and it's one of the prettiest objects in the sky for the to look at with a wide field scope. This is a Hubble picture of it. And you can see it's actually 2 star clusters. And in the lower one, there are a number of orange red giant stars that appear gold in this picture. And if you look at the cluster during dusk, before the sky gets really dark, the color of those orange stars really stands out. They're easy to pick out from the background stars. So it's very dramatic. In a real dark sky like this, the constellation is mostly these blue-white, hot blue-white stars. So, and I changed my background to show a picture of my double cluster picture I took. Kind of hesitate to follow the Hubble picture, but so it's
You're
one of
back,
my
Jerry, show that again, Jerry. Go ahead, show that
it's
again.
one of my favorite objects to photograph with a wide field telescope.
Can we blow that up, Mr. Totten? Is that possible? Is it the same as the background you just showed us?
It's an economy version of the Hubble picture.
Is that double star Achird, ACHIRD?
No, it's a double cluster, Ron, not a double star.
Yeah.
Oh, it's not a double star, double cluster.
Yeah, it's two star clusters that are right next to each other. Achird is one of the stars in the constellation of Cassiopeia.
Would it be safe to say that, I think I brought this up before, I'm trying to imagine star clusters. Inside star clusters, the stars and any planets are only light months from each other, right? Not light years.
That's in a globular, Ron. This
Yeah.
is an open cluster, so it's much more sparse.
Mhm.
Okay, well, what is Achird?
Achird is a double star.
Okay.
It's not
fine here.
listed. It's not on. Go back to the Finder chart for this, where the names of some stars were given. Achird is one of the outlying stars, but I don't recall which.
Well,
Let's see
the
where-
notes you sent say has a bright blue primary and a dimmer orange-red secondary.
Yeah, but those are not resolved in this Finder chart.
Okay.
So Achirds of beautiful.
Is it pronounced Cassiopeia or Cassiopeia?
Either way, I've heard it both ways.
Well, between Cassiopeia, following Perseus is NGC 809 or 869, and another one 880. Those are the numbers of the stars. Okay,
That's the
there we
double
are.
cluster.
It's a
Each of those-
cluster.
yeah.
And-
Just
and
a
what-
quick one here. Do you guys see M103?
Yeah,
Messier 103? Yeah, that was always a favorite at Westmont around Christmas because it looks like a little Christmas tree.
Oh,
Yeah, it's real pretty.
yeah. I've shown that to people before, and the Christmas tree in my scope at an outreach, and the Christmas tree always happens to be upside down.
Same with
so, and so people are looking there, and then I say it's upside down, and then all of a sudden they go, "Oh, I see it now," So
yeah. I just tell them the angels on the bottom.
the angels on the bottom.
I've often heard that the whole tradition of Christmas trees started when people would hang fir trees upside down like that from their roof during the winter.
Yeah,
well, now, is that an asterism?
No, it's a cluster.
It's a cluster.
But okay, but if it looks like a Christmas tree,
Right. You can call it the Christmas tree part of it an asterism.
right.
Yeah.
can't wait to see that one.
It sort of always surprised me that, Messier did see 103, but he never listed the double cluster. That's sort of odd because it's pretty bright.
Yeah, it's
Yeah.
hard to miss.
Yeah.
But maybe he knew he wouldn't be confusing the double cluster with a double comet, so he did.
Yeah, that's true. That's true.
But he did start cheating and including things like the Pleiades just because he wanted to buff up his list.
Oh, okay. Well, anyway, Cassiopeia is in a very target-rich region of the Milky Way. Not as target-rich as Sagittarius and Scorpius, but still quite nice.
Fascinating
I
stuff.
notice on stellarium, the star Shedar is spelled Shedar in it, whereas the one that Jerry brings, it says Cgdar. Are there two
Yeah.
spellings?
Yeah, you'll see
Probably
multiple
more than-
spellings for a lot of these Arabic names.
Okay.
And multiple pronunciations.
Yeah.
My favorite star, and probably the easiest one to pronounce, is Zubin El Ganubi.
Yeah.
Don't forget Zubanesh Shamali.
Oh yeah,
Right, the other clock.
I'm hanging in there, gentlemen, trying to keep up with you.
okay.
Just out of curiosity, that double cluster, how many light years apart?
Are those two?
Yeah, might they be? Just they're not bosom
I
buddies.
don't remember that distance.
Okay, but they're up.
Chuck, you remember?
They're something like 6,000 light years away, if not more, but they're separated by only a couple of hundred light years, I think.
Yeah, okay.
But each cluster has hundreds of thousands of stars.
Yes.
Well,
together.
thousands.
Thousands. So they're mini clusters. Well, fascinating
Yeah, on my
stuff.
C8 with a 100-degree, 20-millimeter eyepiece, the double cluster is just spectacular. It's for the view. Pat, used to really like that.
Yeah.
Well, every night this week, we can see this. This is not just a specific one of our.
If the clouds cooperate,
Oh, that's
you
true.
can see it, and it's because it's not a nebulous object, and you can see it when there's a lot of moonlight out too.
Yeah, and it's kind of an early morning thing right now.
Yes, right.
And once again, from my memory, the big W is a chair, or is it the queen sitting in the chair? What is the constellation look?
There's the queen, and she's sitting in her throne, and you can see the main bright stars as the throne.
I gotcha.
You'll see it drawn different ways, of course, with all these constellations.
Yes.
Oh, we just saw something Tom threw up there. It looked like a chair with a lady in it.
Yeah.
Well, that's
Yeah, her head is down at the bottom. On this one, the head is at the top, which you've got. On Stellarium, it's upside down.
Well, see, in the way I usually see it, she would be upside down here, hanging upside down, and Kaf and Shadar are like legs on the throne, and then Segin is like the back of Segin, and Rukba are like the back of the throne, and she would be hanging upside down. The story is she was always bragging about how beautiful she was, so she was made to hang upside down for at least half the year to kind of make up for the fact that she'd always been bragging about how beautiful she was.
Yeah.
Would it be safe to say, gentlemen, that they can't see Cassiopeia in Australia?
That's right.
Okay.
Unless they're in far, far northern Australia.
Right.
Right.
Really?
Even then, that's
Or in a planetarium.
yeah.
All right, there they are. Kaf, Shadar, Navi, Rukbar, and Sagan. That's my law firm. I've been with those guys for years.
Yeah.
Well, gentlemen, we'll be talking about the Oort cloud. I want to get to the nightly sky starting with today, but real fast, I wanted to pass on to everybody that is not on Jerry's list of the network of email recipients, a forwarded cartoon that cracked me up this past week, sent to all of us, but mostly for outreach coordinator Chuck McPartland. It shows a man sitting in front of his computer, his cat. I started to say nailed to the wall, but no, it's strapped to the wall.
Duct tape.
Yeah.
There it is.
Schrodinger's cat. Yeah.
Show that
Say
cat.
hi.
That's a Siamese, isn't it?
More or less.
We got a movie. We got a theme for the show. It's from Lady and the Tramp. We are Siamese, if you please. Okay.
We are Siamese if you don't please,
If
too.
you
That's the
don't
second
please.
line.
That's right, Peggy Lee. All right, let me tell you what I wrote down from Jerry's notes, everybody, and you can comment or plan on if we don't have an overpay. Interesting this morning, the socked in cloud cover burned off within an hour. I think it's going to be a hot. We're lucky so far. We're out of that incredible heat.
We got into 90 degrees yesterday at my backyard.
Oh, it did.
Briefly, and then it cooled off in the evening, and then it's foggy. It's just now burning off at my place.
But an all-time record in Seattle.
Yes.
Yeah.
That's amazing.
Well, that's
Triple digits there.
Yeah.
Yeah, that's
Oh,
good.
115, I think I heard.
Wow.
in Seattle. I think no, that's Portland. I think Seattle
Portland,
is
yeah,
100.
Portland.
Yeah. Tonight, the 28th, I didn't really give the date, did I? June 28th. This is series 2021 and episode 18. And the moon passes 4 degrees south of Jupiter right after this show, about noon. Jupiter is in Aquarius, nearly 12 degrees below Sadal Melik, the 3rd magnitude star of the water bearer. Aquarius, the planet outshining the stars of the constellation. Jupiter's 4 moons are, I guess, directly west of it.
Yeah, and the
it's easy
picture
to see.
picture that was just up shows the moons Io,
There they are.
Europa, Ganymede, and Callisto, all to the west of Jupiter.
And in the order of their actual distance from Jupiter too.
Yes, but not to scale in this picture.
Yeah.
Okay.
So if we're looking at that in the night sky, the west would mean to the left would have been where the sun set. We're looking.
Yeah, way out there. Yeah,
I got you.
but you can change that by rotating your camera. So, okay, next.
And who wants to name those 4 stars?
Which 4 stars?
Not stars, of moons. I'm sorry.
Jerry
Io,
already did.
He did.
Io,
You did already. Let's see. Io, Gyna. Io is the closest in, isn't it? It's the most
Yeah.
volatile, right?
Yeah.
Of the large moons.
yeah.
Is it a large moon? Is it as big as our moon?
Yes.
Io.
Slightly small.
Almost.
Yeah.
Okay, and it's totally involved in lava and volcanic.
Low
So
temperature lava, yes. Sulfur volcanoes and stuff. So how many moons are there currently for this now? Like 75 or something?
79.
79, okay.
But we only see 4.
We only
Easily.
see 4 in little teeny scopes.
Yeah.
Bruce, are you planning to zero in on Jupiter this week?
Possibly, sure. It's early morning when it's up high.
I was out
Right.
doing an occultation at
2
3
a.m.,
a.m.
something like that.
Yeah, I was up at 3 a.m. and it was prominent in the southeast with the moon and Saturn.
Okay.
Can we hit you later in the program, Chuck, with an occultation report? You want to tell us more about that when we get through these night sky? week?
Sure, there have been a couple of new results.
All right, well, let's go through Tuesday real quick if you're done with Monday. Let's see, an hour after sunset. This is Ursa Major. It's balanced on her front paws above her head. That would be the Bear, pair of galaxies, M81 and M82, both nearby spiral galaxies who had close passes several 100 million years ago, with some gravitational effects spawning some new star formation. The two appear a little more than a half a degree apart in the sky. M81 is also called Bode's galaxy. Bode's or Bode?
Bode.
Bode's galaxy.
Bode.
Johann Bode discovered it. M82 is the cigar. Oh, there it is.
Yeah.
And it's long and slim. M81 is brighter. But
Actually, M82 is brighter.
Well, it appears brighter.
Appears
It has
brighter.
higher surface
Yeah.
brightness.
okay.
yeah.
Well, M81 is bigger, right? Because it's side on, or rather full
Face on. All right.
face on, right?
Jerry, is this your picture?
No, no,
Okay.
no.
I was going to say it's cool. You caught all the erupting hydrogen from the cigar.
In pictures I take of it, I can see that stuff, but not this vividly. This is an excellent processed film. You can see faint clouds around the galaxy, M81, and this continuation of the spiral arms out into the space between the two galaxies.
Do you suppose they're as close as we are to Andromeda, or are they just, God knows how many?
They're
thousands?
closer. They're
Yeah.
only about 300,000 light years apart.
Right.
Really?
So they're
it's about-
12.8 million light years from us.
Mhm.
Wow. Well,
So
can
it's
you
about
see
10
it?
times closer than we are to Andromeda.
Can't see them with binoculars, can we?
Oh,
Yeah.
yes. Yeah, they're
Oh,
very
yeah.
small objects. Yeah, they're easy objects, and they're very impressive in a scope, when the moon's not up.
And Johann Bode was named on the first one. Did he not see the cigar next to it? Or he
I
just
don't-
didn't get his,
I don't
Name
know
it.
that, but
I don't imagine he could have missed it, but he
Yeah.
probably described this Messier object first.
Okay, well, and then Messier came along, and Messier came after Bode, I assume, right?
Mhm. Well, before the 20th century, these things were called spiral nebula. They're galaxies, and this one does not. The other one, the Edge-on, does not look like a spiral nebula. So the true nature of these objects were unknown at that time.
Wow.
So he might have dismissed that one as just a bright spot.
We can't tell if it's barred or even spiral, right, on the edge, the cigar?
No.
Well, it has a lot of dust,
Yeah.
dust clouds along its central axis, implying that it's a spiral, but we're seeing it edge on. But it's also been tidally distorted by its interactions with M81. So it was called an irregular galaxy in the past, but I think we now think it's just a
active galaxy.
edge-on spiral starburst galaxy because of tidal disruption.
Starburst or Seifert. Yeah.
Yeah.
Okay,
Oh, here's that supernova from a while back.
Yeah.
Yeah, I got a picture of that.
In which galaxy did we have a supernova?
In the cigar.
M82.
Oh, really?
Yeah, that's up on the screen now. See, there's a picture above that's without the galaxy, without the supernova,
Yeah.
and then
there it
below
is.
the supernova. Supernovas are easy to spot because they have little lines next to them or little arrows.
Arrows, yeah. And this was an easy one to get. I mean, even if you were unfamiliar with the galaxy, because you can see those two bright stars below and kind of to the right, and they sort of pointed to where the supernova was going to be.
Yeah. Yeah, one of my students imaged this at Westmont.
Really? What are your
Yeah,
students?
Jack Jackson Kwiatkowski was his name. He's long since graduated. Yeah,
But it is.
Did you get a nice crisp picture?
yeah, with the 8-inch.
Okay, because I did mine with the 8-inch, but there was enough turbulence that night on a 30-second exposure. It made the stars and the supernova, round, not points.
I see.
Well, this was visible for weeks, so you could have taken it on a good night.
Mm-hmm.
Well, I took it on a bad night, I guess.
Are supernovas typically just a few weeks and that's it, or do some of them last for years, or some are flame out in a day?
They're more like weeks, at least for bright, really bright visibility.
But it depends on how close we are to it.
Yeah.
Do we happen to know when this happened? How many years ago?
12 million years.
Yeah, plus 2014
12.8
minus 12 million years.
It appeared to happen just a few years ago.
Yeah, okay. And we haven't seen any since then. I mean, we're checking all the different galaxies out
Ron,
there.
There's thousands of supernovas discovered every night.
Are there really?
Yeah.
And you're dealing with occulting asteroids? You should be out looking for those.
Oh, there's enough people that look for those with really big scopes that I'd be wasting my time with a 5-inch.
And we go on to Wednesday, gentlemen, the last day of the month, 2 days away, early in the morning, 2 hours before sunrise. Uranus will be 14 degrees high in the eastern sky. Inside Aries, the Ram. Use your binoculars to see it. Just 11. What's the single quote sign? Is that minutes or arcs?
Minutes.
Arc minutes.
Minutes. Okay, the double would be
Seconds.
Seconds.
seconds. There's no such thing as an arc, is there? Okay, I'm still.
Oh, these are arc minutes and arc seconds, Ron.
Okay. And let's see here. I get my light on here. It's due north of Omicron Arietis, a star that's about as bright, just about as bright here. And then check out nearby Taurus. I'm not sure. We're on the Wednesday sky here. This would be Wednesday evening. Taurus, let's see, we're M45, Messier 45. The Pleiades are rising. Now, is that a star cluster?
Yep.
That's an open cluster.
Yeah.
Well, what's the difference?
Well, there's a globular cluster, which is the spherical hundreds of thousands of stars that are very old. And then there are open clusters, which are thousands of stars and very young.
Well, I believe the term you were using earlier in the program was star clusters, the doubles,
Yes. But there are globular clusters and there are open clusters.
Open clusters. And so the Pleiades
is an open cluster.
And it's a famous grouping of young stars, often mistaken for the Little Dipper, but it's not. It's larger.
It would be sort of a micro dipper.
Okay.
It has a faint appearance of a Little Dipper shape.
We get people at outreaches all the time that are saying, "Oh, there's the Little Dipper." So
Yeah.
Right. Yeah.
I've seen it, and it seems to have 5 stars. You can see only one in the handle. Is that right?
Yeah.
Am I off?
It depends again on your eyes. Matter of fact, how many stars you see in the Pleiades is an eye test.
Okay, it'll be upside down in the north end of the, let's see, the handle is Polaris. Polaris, the North Star, is in the Little Dipper, or in,
Yes,
oh, this isn't the Little.
It's the very end of the Little Dipper, the handle.
yeah, this is the Pleiades here in this image.
Yeah.
Are we talking about another dreaded asterism?
Well, the Little Dipper is an asterism, yes. So is the Big Dipper.
But this one isn't.
This one
Pleiades.
can be.
Yeah.
Okay.
If you recognize a shape in there, then you could call it an asterism.
Yeah, asterism is a very generic term, Ron.
Right.
When
And you
we
can see the detail in the Merope Nebula.
Yeah.
These stars are actually moving through dust and gas in space, and they just light up. They just light up the arena. It's really pretty.
But just because you see a grouping of stars close together doesn't mean they're real close. Some of them could be really far beyond. And
Some of them, that's true. This one is close to itself relative. It's part of a real cluster. But if you like it as an asterism, we can call it the Barron's asterism.
Yeah.
Okay.
Or the ladies who ate onions.
Yeah.
Yeah.
Going to be hearing about Barron's asterism every time we gather and convene on Mondays, gentlemen. What is that? What is the picture we just saw? What, Tom, what are you throwing up?
Different versions of the Pleiades, how people have seen them.
Oh, well, that's interesting. Little fairies, and there's some ancient.
This is like a shield that was dug up in Europe that some people are saying could be a very early representation of the Pleiades. They're kind of in the middle between the moon and the other sun, I guess.
Between the moon and the moon, yeah. And it looks like a happy something.
Yeah.
Well,
Oh yeah, turn it.
okay, turn it upside down. That's fascinating. Wow. That didn't come to in Jerry's notes.
No,
Some extra stuff.
Tom's ad-libbing.
Yeah.
Good for you, Tom. Welcome back, incidentally.
Look at in that previous one, look at how small the field of view of the Hubble is. Especially the Whiff Pick 2 there in the middle. It looks like a little B-2 bomber. It's an amazingly small field of view.
Yeah.
Which one are you looking at, Chuck?
Those are fields of view there, that
FBC2.
little arc in the upper left, kind of.
Nope, not
And then
that
right
one.
in the middle of that, there's this little thing that looks like a B-2
There.
bomber,
Oh, yeah.
and that's the Whiff Pick, the wide field planetary camera. But that's really not a very wide field.
Uh-uh.
Huh. Does the Hubble just have one standard field that doesn't
No.
expand or zero in on anything?
Well, it depends which camera you're using on it,
Oh,
which instrument.
okay. But they all use the same reflector, right?
The same
they have
optical train.
the mirror in the
Yeah.
back. Yeah, that's the one. How close is it to the Big Dipper? It's not part of the Big Dipper, is it?
No, it's in Taurus the Bull.
Yeah,
Oh, it's Taurus the Bull.
different parts of the sky.
That's my sound. My sign.
As you can see on the finder chart for Thursday.
Gotcha. Okay, gentlemen. Takes care of Wednesday. We still got the Oort cloud to talk about in the next half
Yeah,
hour.
it's coming up.
And they just found an incoming piece, they think, of the Oort cloud, right? That in 2031 is going to pass through the solar system, but it's on its way in now, and it's already showing cometary activity, but it probably won't get bright enough to see naked eye. But it's huge. It's like 100
I think it's
kilometers
coming in.
across.
Isn't it coming into about Saturn's orbit?
Yeah,
The closest it'll get to the sun.
Was it discovered in 2014? Because it's
No.
named
uh,
2014 UN 271 or 27. I can't.
that might be when it was first imaged, and now they've got the orbit for it.
Mhm.
Trans-Neptunian object. Okay, so you don't want to do Thursday and Friday and then jump into Oort cloud real
Yeah.
quick?
Thursday's good.
All right, let's go to this first day of July, right around the corner, 7/1. Time to welcome Mercury to the morning sky an hour before sunrise. It'll be ascending in the east with the horns of Taurus the bull. Ferdinand, my buddy, a half hour before sunup. Mercury will be a scant 7 degrees high, glowing at magnitude 0.8. And it's east-northeast of Aldebaran, eye of the bull. Binoculars okay, everybody, but stop looking by sunrise as the sun will wash it out. It's a little close there, isn't it?
Yeah, you don't want to accidentally pick up the sun in anything. And you can see M1 down past Mercury. That's a planetary nebula that is a
No, it's a supernova remnant.
yeah, but
Right.
that's right.
Yeah, the Crab Nebula.
Yeah,
Yeah.
it's a small, compact planetary-like nebula.
He squeezed out of that one.
It's not M1.
I keep calling it a planetary nebula because
And this new class of supernova that they just confirmed with the Las Cumbres Observatory, they think that the progenitor of the Crab Nebula was one of those types of supernova.
yeah, an electron capture
Yeah.
supernova.
All right, well, I'm still on
We'll talk more about that next week.
Oh, okay. Give us some goodies. Well,
Yeah.
we'll wrap up Thursday here. Last quarter moon happens at 2:11 p.m. in the afternoon. Starts its waning cycle, shrinking to a crescent, and a new moon on July the 9th. Friday, the 2nd of July. This month, a race between Venus and Mars in the after sunset sky. Over the next few weeks, Venus will overtake Mars as they skim across Cancer. End of the month, inside Leo the Lion. Venus that evening, Friday, will be at magnitude minus 3.9. Is that correct? What is the minus?
Right.
Means it's bright.
Oh, it's very
Brighter than zero.
Yeah.
below zero. Okay, below zero is brighter.
Yeah.
Within the let's see, north regions of the Beehive star cluster. Here we go. Another cluster.
Upper right, M44.
M44 is the Beehive.
Mm-hmm.
And you
Please find
see
it on there. Where is it on
you
there?
see
I
the
don't.
lines. The yellow line is Venus, and the orange line is Mars. And you see the 10 and the 10 almost line up on the two, and then the 15 and the 15 have passed each other. So between those two sets of lines, but closer to the 10, that's when the two planets will be the closest to each other.
July 12th it happens, and they're half a degree apart.
So that's going to be an impressive image to take.
And it'll have a nice crescent moon near it too.
Yes,
And that cluster is known as M44.
M44, the Beehive.
Beehive.
And it's a naked eye visible object under a dark sky.
Does the name Praesepe mean anything to you? Praese.
The manger. It's the manger.
Manger?
Yeah, it means the manger. There are two stars near it that are called the northern ass and the southern ass, and they're two donkeys that are eating out of the manger.
Yeah.
So the Bible and the scriptures got into the sky here somehow. That's interesting.
Well, no,
Yeah, not in this
manger,
case.
Praesepe and manger are used in the Bible, but they're not referring in this case to the Bible. It's just a trough used to feed animals.
It's true. You're absolutely right. So the only time I, growing up, saw a manger was a biblical,
In a creche. There's no constellation of the creche that I know of.
So they're going to set at 10 p.m. Friday night in the western horizon. Astrophotographers, of which we have many on the screen and in our club, will have a field day. Just over 6 degrees east of Venus sits Mars, somewhat, what's the word I wrote down? Fainter at magnitude 1.8. Red planet spans 4 minutes, right? Seconds. All right.
Yeah, it better not be minutes.
Arc seconds. Arc
seconds.
TomT, do you understand all of that? Degrees, minutes, arcs?
Oh yeah, he knows it all.
Yeah,
Oh, yeah.
apostrophes and quote marks. I like those. Sure.
And don't forget about people like me who really enjoy binoculars. So be able to see this stuff with
Binoculars are the most frustrating thing for me in astronomy because I can't hold them steady.
Yeah.
Because I'm too cheap to buy image stabilized binoculars. And
I just use my birding 8x42s as
Okay.
wonderful view.
and you hand hold them?
Oh yeah, oh yeah. Mhm.
Okay. And the other thing is I can't get both fields to register with my eyes. So
I have that same problem, but it depends on which of my binoculars I'm looking through. My Bushnell binoculars, I can see just fine. I have a pair of Celestial binoculars, which have a really nice wide field of view, but I get a double image.
yeah.
Well, we're certainly not going to get a stereoscopic view of deep space and see the closer stars in and the
No.
more in-depth stars with a pair of binocs.
But you're much
I
more
just close
likely
my
to
right eye.
you're much more likely to get that effect, at least mentally, using binoculars, especially looking at something like a thin crescent moon.
I see.
It looks very
Chuck,
3D.
since we're in between here and we got about 20 minutes, so you want to give us an update on who's occulting where and what you've been up in the middle of the night doing? And poor Pat has to get up with you probably, or maybe she sleeps through it all.
She sleeps through it all. No, there have been a couple of occultations. I haven't had a positive since Patroclus a while back, which was the double asteroid, but they just discovered a potential new double asteroid called Arecibo. It was named after the Arecibo Observatory. Tom, is it all right if I do a screen share?
Oh, go ahead. Sure.
Okay, yeah. This was on June 9th. And it was up by Atascadero, I think. A couple of guys were there with their telescopes to catch this occultation. And they were only expecting the main body there on the right, the yellow, the bright yellow circle. And instead they got a double occultation. So this was the second time that this was seen. And then it was seen a third time in a subsequent occultation. So it's considered a discovery once you get enough observations like that. So it's a discovery that this is actually a double asteroid.
Oh,
Are they in orbit?
Yes.
huh.
And in fact, there's a campaign now. None of them are coming close to here, but there's a campaign now to observe occultations by this pair to pin down the orbit of the smaller one, and that will give you an idea of the density of the two objects by figuring out the orbit. So they're really actively going after Arecibo here.
So I'm a little confused by the diagram there. It looks like the red line and the purple lines are on the left of the big object, but not on the right. So the same observer didn't see it coming out. I don't know which way it's going.
Yeah, no, it's the same observer. You can see K Bender,
Oh, yeah.
Arnolfinius there on the right.
Yeah.
It's just that they when there's two, I think this program doesn't expect that.
Oh, I see.
So it ends up coloring them differently.
Yeah, I get it. So, and where are these? Just, it says near and near, but then the words are missing. Where were these observations made near?
Okay, it looks like Bradley and some other town, in Central California.
Okay, Central California. Okay.
Yeah. This is just a clip, so that's been put up at the results site, so I can't really expand that window and see what the name is.
I understand.
But did you see it, Chuck?
No, I did not observe this one.
Okay. What did you observe this morning again? Recap.
This morning was an object called 2002 SX 362.
Okay.
And I didn't get a useful observation of it because I had wispy thin clouds and the moon, and it was a very dim star, so it just wiped it out. I didn't get any useful data.
All right. For the benefit of anybody tuning in that doesn't know what the hell we're talking about, you might want to briefly explain. Occasionally an asteroid, which you can't see, will obliterate a star. Then they know when these are about to happen, don't they? They tell you in advance.
They make predictions that may or may not be accurate. Yeah.
Uh-huh.
And it may not totally, the asteroid might be brighter than the star, but in that case, the total system dims down a little bit when the star is occulted, or the asteroid could be invisible and then you just see the star disappear.
But are there ever any major stars, any Vegas or Aldebarans that get occulted?
Yeah.
Oh, yes.
Yeah. There was an occultation of, I believe, Rigel or Regulus in 2012, I think it was, that everybody, I think it was 2012. Anyway, it was going to be visible on the eastern seaboard. That was when you could watch naked eye, But unfortunately, at the time it happened, the entire eastern seaboard was covered with clouds. So nobody got to see it visually.
All right. So some nights you have many, many occultations, other nights none at all or
Yeah.
planned?
Yeah, the most I think I've had in one night is 4.
4, the most. And how often do you get notice that one's about to happen and you zero in, you plug in the, you get all set up and it doesn't happen for whatever reason?
Oh, probably about 9 out of 10 times that I try, it doesn't happen. But I try ones even when I'm in the 2 sigma zone where it's not likely to happen, because the orbits aren't exact and the star positions, especially for brighter stars, aren't exact. And so I've actually hit quite a few that were not very likely, considering. So I still try.
As Chuck has pointed out in the past, even a miss is useful information.
Yeah.
Yeah, if you're a miss, they know that, you know, for example, it didn't pass. If I'm to the south, they know it didn't pass south of the star.
Yeah.
But they're discovering exoplanets by simply seeing the star dim a little, knowing that
Yes.
it crosses. Does that ever happen with an asteroid? Just dim
Yes.
the star? It
Well,
does.
no, it doesn't just dim the star. The stars are so far away, they're essentially point sources. But when the
Oh.
asteroid is brighter than the star and goes in front of it, you get kind of an inverse of an exoplanet discovery, in that the system dims down as a whole, but you're still seeing the asteroid.
How far ahead do you know?
Okay, here it was, Regulus in 2014. And you could see it was going over New York, so everybody thought, oh, cool, the whole, you know, there's going to be
Whoa.
lots of observers,
Good heavens.
and it ended up clouded out.
Looked like it was pretty close.
Yeah, in that animation.
You wouldn't have been privy to that one out here, right? At
No,
all.
that's correct.
Okay. What's ahead? Do you, how far ahead do you know that, what's your planned schedule outside the weeks?
Oh, there are, you know, you can look a year or so into the future for some events.
Really?
But the accuracy increases as the date approaches. You know, there are updates that come from the Minor Planet Center in the orbits.
Yeah.
And so the closer to the date that you look up the event, the more accurate the prediction is.
But now there are just as many in that Trojan field around Jupiter and that Jupiter's orbit as there are in the asteroid belt, which is
No,
close.
not nearly as many.
Not nearly as many. Okay, fascinating. Can we get into Oort cloud real quick? Do we need an explanation for the benefit of anybody that doesn't know what the heck an OORT cloud, named for Jan, I think his name?
John.
What?
Jan Oort.
Oort.
Jan,
Say
1950.
it Y-A-N.
And unlike the occulting asteroids, we don't see any of those suckers out there. They're too far, aren't they? But
Well, but when they're out there, they're too far, but we see them when they come in close, and that's how we have postulated that it's there.
okay,
So-
that's where all the comets come from.
Yeah,
Not all, but a bunch.
right.
Some of them come from the Kuiper belt. Now everything else is a belt, but this is actually a shell, isn't it?
Yes.
And you can see in that drawing how the layout kind of looks. You can see
Huh.
you see how you got that sort of
Two
figure
hemispheres.
8 there, and the disk part is the bar across the center there. That's the Kuiper belt, and then the Oort cloud is spread out.
Same stuff. Rocks and ice.
Yeah, more ice.
Is it basically the same stuff as in Saturn's rings?
Yeah,
Most
Saturn's
likely,
rings are
probably.
at least spectrally almost pure water ice, but that just may be because the rock and dust is coated with water ice.
Okay, well, apparently there's a visitor let's see, this is from Jerry's forwarded fact, visitor in the Oort cloud, from the Oort cloud. So it's out of the Oort cloud and coming into our solar system, 2014 UN 27 or 271, I can't tell. It's a trans-Neptunian object on a cometary-like orbit from the Oort cloud. And as of 2021, which is this year, it's currently approaching the sun at a distance of 20.2 AU, which is 3 billion kilometers, will reach perihelion, which means it's closest to the sun at 10.9 AU, just outside Saturn's orbit. Then
Yeah,
then
that's
what? I don't
It'll
understand.
go back, it'll go back out to the Oort cloud.
Okay, so it'll be swinging around. Does it go pretty much in the same orbital?
Oh, I don't
direction
know that, whether it's retrograde or prograde, I don't know. I don't
Yeah,
know.
another thing to notice is that the x-axis there is logarithmic.
Yeah, I think this might be a little misleading in that.
Yeah.
It is, unless you're really used to logarithmic scales.
Mhm.
Could you go back to the three things about the asteroid belt, Oort cloud, and the Kuiper belt, the picture? I want to make a comment.
And,
Yeah,
and the whole reason they speculate about this Oort cloud is you get things that aren't in the plane of the solar system. You know?
Right. So you see that the Oort cloud is spherical like this. The Kuiper belt is a flat ring in the plane of the ecliptic, and so is the asteroid belt. Do you have any idea why the Oort cloud hasn't collapsed into a disk? Okay, I'll take the silence as no. So the object starts out like even stars start as a three-dimensional clump of matter that is gravitationally attracted. But each individual particle of the cloud has some random motion. They're all just swirling around somewhere. And it has to be a high enough density, that is, they have to be close enough so they regularly collide. And eventually, when they regularly collide, they all assume the average angular momentum about things, which defines a polar or axis of the disk. And then gravity causes them to collapse. There's nothing to resist the collapse to the plane, but in the plane, the angular momentum keeps them from falling in. So everything goes to a disk when you have a cloud of things, if the cloud is dense enough, to a ring around a planet or the plane of the asteroid belt or the plane of the Kuiper belt. But the Oort cloud is believed to be low enough density that they have not assumed a singular angular momentum yet. If they did that, then it would take a very long time to do it with the low density. And so it hasn't assumed an average angular momentum to then collapse into a disk. Clear as mud? Nope.
So
And,
that,
you know, just the rate of collision, because it's so sparse, the rate of collision doesn't cause them to interact that much. So they retain their original angular momentum
Right.
and motion.
all right. Well, explain this.
Well, is the Oort cloud a disk or is it a sphere?
It's
a sphere.
That's what I
Oh.
thought. So this is like a slice through a tomato.
Yes.
Exactly. Yeah,
Right.
it's not a plane that we're looking straight on at. Yeah.
But there
And if you
there
look
are
90
denser
degrees,
areas.
you'll see the same thing.
Yes.
Yeah.
If you do what, you see the same thing? What did you
If
say?
you were to look
If you
from the
looked at it
pole
from 90
versus,
degrees away.
Oh,
it would look the same.
Well, if you were looking from the pole, you wouldn't see that condensation from the Kuiper belt. I mean, you'd be looking down on that, so it might look a little different.
Yeah. I assumed he meant 90 degrees around the equator, but yeah.
okay. Couple of quick questions. Number one, why wasn't Oumuamua, the cigar-shaped visitor they call from another galaxy or another star system,
Or a disc shape. They
Why
can't tell between the two.
or what?
Or a
What is-
disc shape. They can't tell between the two.
Okay, but
It's a ratio of 1 to 10.
Oumuamua came through. It could have. Why couldn't it have come from the Oort cloud?
It probably did, or it might have come beyond the Oort cloud. You
Yeah,
can
its
measure-
velocity was such that it was not gravitationally bound to the sun.
Yeah, so therefore it came from beyond the Oort cloud.
Okay, so way back at the very beginning, when the solar system was formed, that was what was inside this, or was it just everywhere? This dust cloud. It wasn't a big ball back then. It's sort of, that's the refuse, the debris that's left. It's
Yes.
still in the shell form. It didn't get down into the accretion disk or whatever that's called that became our ecliptic.
Yep.
And your miniature, your dwarf planets, your Plutos, those aren't out there in the Oort cloud. They're only in the Kuiper belt, right?
Right.
Yes.
Mhm.
Although this object coming in from the Oort cloud is big enough that it might be classified as a dwarf planet.
Mhm.
And planet X or planet 9, even though X stands for 10, but it's probably an Oort cloud object.
Oh, really? They think there's a planet out there that would be.
Maybe it's, they're defining an envelope. It could be in the outer reaches of the Kuiper belt, but
Okay. And they can tell this.
It's speculative.
Yeah, I know. And they can't find it. We can see the deep field all the way to the other side of the universe, but we can't find a 10th planet or 9th planet. I guess Pluto was demoted. Fascinating stuff. Is there a name for this visitor other than what we're calling it here?
Not yet.
Not yet. The two.
That's a funny name.
What?
That's a funny name.
What?
Not yet.
Not yet. We got to get a funny line to close the show out from Mr. Whittemore.
Well, you know, Elon Musk
Ron-
called one of his recovery ships, "You know, I still love you."
So, Ron, when you were naming the stars of Cassiopeia, and you said it sounds like a bunch of lawyers.
Oh, right.
Or yeah,
My
I
law
was
firm.
just going to recommend another set of lawyers: Dewey, Cheatham, and Howe.
That's from the Three Stooges.
That's right.
Our guy.
Yeah, I've been a
Or
lot
take
of
them, rake them, and how.
That sort of
Yeah.
dates you, Jerry.
Yeah, I think I dated myself earlier.
Yeah.
Well, this has been fun. I'm going to go check out your expanded Hertzsprung Russell diagram you sent and see if I can see the humor in that. I don't.
I couldn't get that.
Did that? That's a separate.
Oh, I did get that one. The other one which he had, which was the map of the United States with all kinds of stirred up names on it. I didn't quite get what the issue was there.
Those were the positions of every city that has a famous name, but it's in the wrong place.
Oh, all right. Okay.
Like
Okay.
Moscow, New York.
Okay.
Moscow, Idaho. Yeah.
Yeah, Moscow. Yeah.
Okay. Now I understand.
Took me a while to figure that one out too, but it was fascinating. But I didn't see the word Springfield, and there's a lot of Springfields.
Yeah.
Missouri.
He's showing the Hertzsprung-Russell diagram.
Oh, there
And
we
you
are.
can see down in the lower right, you can see the luminosity versus the effective temperature of an astronomer.
Right.
Now, this illustrates a log scale. So it's 10 to the, what is it? 10 to the, I can't read the exponent on the bottom number.
10 to the 0.
10 to the 0. Oh, yeah. And then 10 to the 30, 10 to the 40 actually up at the top. So that's quite a range of emission. But Jupiter, Earth, Mars, Europa, those, and France, they're all in there.
Huh. And is it possible to explain briefly what the heck it is? Brightness?
Well, as you can see,
Versus-
astronomers are pretty dim. Okay.
New bumper sticker.
Yeah.
It's
Okay, so we
effective-
we radiate at some effective temperature. All right, and it's above absolute 0. So you can see if you move up from the astronomer to the top line, that gives you our effective temperature that we're radiating at if we were a black body.
in Kelvin.
Yeah, in Kelvin. And then
Gotcha.
down here on the lower left, you can see how many watts we're giving off of heat.
Yeah.
Which is luminosity.
Mm.
So
All right.
that's where we appear on a Hertzsprung-Russell diagram.
If you look at a human being with an IR camera tuned to the 11, 12 micron band, long wavelength IR, people look like light bulbs. We all glow by
About 100 watts.
by our own lights, by our own, energy.
Is that the part of the electromagnetic spectrum, the Webb telescope, that's infrared, or is that ultraviolet?
There's
Infrared.
Infrared. It's not
Infrared
radio.
web is
We can't see in infrared, thank God.
not with your eyes, no.
Before we go, we might want to consider, I don't know if this is worth a topic next week or not. You've heard the Pentagon's report on UFOs, now called UAPs, I guess, unauthorized aerial phenomena.
Yeah, otherwise known as drones.
Yeah.
Well, they at least admitted for the first time in 65 years there's something there. They just don't know what it is.
Oh,
And,
everybody's all nations and people are playing with all sorts of secret things.
ooh,
So
If you look at the actual data, most of them are insufficient data to make a determination, because
yeah.
Right.
So let's end with a question for next week to ponder. And that
okay.
is that, as Barron says, people can't see in the infrared, but I know of at least 2 animals that can see in the infrared. So
Let me
what
guess.
are they?
and they don't necessarily use their eyes.
Yeah, well, that's not.
Snake.
Snakes.
A snake is one.
Yeah, but they don't use their eyes.
no,
That's
they-
correct. That's
They have
right. They have-
specialized organs. And the other one is,
Bats.
Mosquitoes.
Mosquitoes, okay.
Mosquitoes.
That's
Oh,
how they
wouldn't
find
you
you in
know
the
it?
dark.
God, how in the world in that tiny little money did they get all that in there? We've run out of time, gentlemen. It's time to click off and talk to our wives and get together again. And every Monday morning, 11 o'clock, it's the SBAU Astro Hour. Thank you, Tom, Jerry, Tom, and Bruce and Chuck. And let's gather again next Monday morning, 11 a.m. Fair enough?
All right,
Right.
thank you.
Yeah.
Appreciate
Good.
it.
Bye.
Thank
Now.
you.